So we are going to solve some equations that happen to have logarithms in them. And so on these first ones, we're going to do that little thing where we rearranged them. And we said, okay, if I had log base b of x equals y, we could put it into exponential form as
log y? No. Log x?
b to the y power equals x, right? And we got rid of the word log from our equation. So normally if you just have the word log in there once, that's the way you're going to approach it to get rid of the log so that you can solve it. So if I have log base 4 of 2x minus 3 equals 3, and I rearrange it into exponential form, I'm going to write it as 4 to the third power equals the 2x minus 3. Exactly. 4 to the third power. Four to the third power is?
Oh. What is it saying?
Okay, 64. Right, 4 times 4 times 4 is 64. Equals 2x minus 3. So then I'm going to add my 3. So 67 equals 2x. And then I'm going to divide by 2. And so x is going to equal 67 over 2. That is a weird answer. When we have a logarithm, this part in the parentheses cannot be 0 or negative. And so you would want to double check for that, but I'm pretty sure this one's not going to give you 0 or negative, because 67 halves would be 30 something, times 2 is 60 something, minus 3, yep, I'm still bigger than 0. But you do want to check this. If you have a negative or 0 in there, you can't do the log of 0 and you can't do the log of a negative number, so then you'd have to say no solution.
Give us an example of that. Is there an example of that?
I don't remember. So, if we rearrange this one and put it in exponential form, we would write it as 3 cubed equals 2x minus 6. So solving that, 3 cubed is 27 equals 2x minus 6. We are then going to plus our 6, and we would get 33 equals 2x. And then, of course, we're going to divide. So x is 33 halves. So again here, if I take 33 and divide it by 2, I'm going to be over 15 anyway. 15 times 2 is 30. 30 minus 6 is still going to give me a positive number. So try number 3. So if I rewrote that one in exponential form, I would have
2 cubed.
2 cubed equals
Negative 3x equals 5.
negative 3x plus 5. So we would then have 8 equals negative 3x plus 5. We are then going to minus our 5, and we get 3 equals negative 3x. And then we're going to divide by negative 3. So x equals negative 1. That's an easier one to check. But negative 3 times negative 1 is a positive 3. 3 plus 5 is positive 8. So it is okay to have that answer. So I'm just going to plug it in. I'm going to plug that number in here. And as long as it's not 0 or negative, when we solve it, we're all right. So now they're going to have you do a multi-step one. So same kind of thing. I have the word log in there once, so I want to be able to rearrange it in exponential form. But before I do that, I want to get that logarithmic term by itself. So on this one, the first thing I need to do is move my 6 over to the other side so that the log is all by itself. So I'm going to add my 6, right? So log base 3 of x minus 8 would equal 4. Now it's basically the same thing we did on the previous problems. So we're going to rewrite that as
3 to the 4th.
3 to the 4th equals x minus 8. 3 to the 4th power would be 81 equals x minus 8. And so then we're going to add our 8 and we get 89. 89 checks out because 89 minus 8 is still going to be a positive number, right? So number 5, if I want to get the logarithm by itself, what might I do first?
Add the 4.
Not add the 4.
Divide the 4.
Divide by negative 4, right? I'm going to divide by that negative 4. And so I'm going to get the log base 4 of negative 2x equals positive 1 then, right? And so rearranging that into exponential form, I would have
4 to the 1st.
4 to the 1st equals negative 2x. So if 4 equals negative 2x, I'm going to divide by negative 2 and I get negative 2 for my answer, right? Checking that out, negative 2 times negative 2 is a positive 4, so that's okay to have for your answer. Number 6 then. Oh, I better let you do that one. So the first thing we did was plus the 7. Log base 3 of x plus 7 equaled 3 then. We then put it in exponential form and had
3 to the 3rd.
3 to the 3rd equals x plus 7. 3 to the 3rd is 27 equals x plus 7. And we subtract. Our answer was 20, right?
Yep.
20 plus 7 is 27, so that checks out. That is okay to have for your answer. All right, the next 3. Solving an equation that has logarithms on both sides. If I have the logarithm on both sides, I want to move them over so that both of my logarithms are on the same side so that I can use my rule. If I'm adding logarithms, I can combine them into one by multiplying. If I'm subtracting logarithms, I can combine them into one by dividing. So if you have more than one logarithm, you want to move anything with the word log to one side, everything else on the other side. So in this case, I'm going to have the log base 2 of x minus 1. This is going to become plus log base 2 of x minus 7. I'm going to leave the 4 over there. I am adding logarithms, so I can combine that into one single logarithm like we did the other day. It's going to be log base 2 of x minus 1 times x minus 7 equals 4 then. Right? When we add logarithms, then we multiply those values. If we're subtracting, we end up dividing them.
Multiply what values?
This one and this one.
Okay, we don't do anything with the log numbers?
Nope, because they're both log base 2. They have to be the same, otherwise we couldn't combine them.
If they were different?
If they're different, we'd be stuck and we couldn't solve the problem.
Okay.
So they better not do that to you. So now that we've got it written as a single logarithm, now we can rearrange it into exponential form like we did on the previous problems. I'm going to have 2 to the 4th power equals my x minus 1 times my x minus 7.
I have a question.
Uh-huh.
Why did we add in the beginning, add the logarithm?
Because this was a negative, so when I moved it over on this side, I had to change it to a positive, right?
What was, change what to?
I was subtracting that logarithm over there.
Oh yeah, we left the 4, I was gonna say.
Right, we left the 4 where it was, we moved the logarithm over, so when it was negative, we had to make it positive, right?
Alright.
So 2 to the 4th power is 16. We're also going to FOIL out my x minus 1 times my x minus 7, so I would get
X squared minus 8x plus 7.
and of course, since I have a quadratic expression, I have to set it equal to 0 and solve it by factoring. So I want to subtract my 16. So I'm going to have x squared minus 8x. 7 minus 16 would give me minus 9 equals 0.
How did we get 2 to the 4th?
Because
Oh, yeah.
2 to the 4th
Oh yeah.
equal my... And now we got to factor it out. So yep, 2 sets of parentheses, x and x, my signs, plus and a minus, factors of 9. I want a minus 8 in the middle, a plus 1 and a minus 9. Which means if x plus 1 equals 0, I'm going to get a minus 1 answer. And if x minus 9 equals 0, I get a positive 9 answer, right? Now, same thing with my logarithms. I can't do the log of 0 or a negative number, so I do need to check both of those. If I would substitute a negative 1 in here, negative 1 minus 1 is negative 2. I can't do the log of a negative 2, so I can't include that in my answers. 9 minus 1 is 8, that's okay. 9 minus 7, that's okay, so the 9's going to work. So I'm just going to put in the answer x equals 9. So always when you have logarithms, you want to go back and check to make sure you're not getting an undefined value. Just like you would if there was a fraction. So number 8, we want to solve that one for x. Again, if you have more than one logarithm, you want to move anything with the word log to one side, anything that doesn't have the word log to the other side. I normally like my logarithms to be positive if I can make them that way. So I prefer to move this over here so that I have 2 logarithms that are positive instead of 2 logarithms that are negative. So I have log base 5 of x plus 2. This is going to become plus log base 5 of x plus 6. And then I'm going to move my 1 over to the other side, so it's going to be a positive 1 instead of a negative 1. So now I can combine my logarithms into a single expression since they're both log base 5. So I would have log base 5 of x plus 2 times x plus 6 equals my 1. So if I rearrange that into exponential form, I would have what?
Go to the
5 to the first equals
X plus 2, X plus 6.
x plus 2 times x plus 6. We know 5 to the first is just 5, and we got to FOIL out the x plus 2 times the x plus 6, which would be
X squared plus 8x plus 12.
x squared plus 8x plus 12. Again, we have a quadratic expression, so we have to set it equal to 0. So we're going to minus our 5, and we get x squared plus 8x plus 7 equals 0 then. And then we get to solve that by factoring. That factors into
Plus 7 plus 1.
x plus 7 and x plus 1, which means my 2 possible answers are
Negative 7 and negative 1.
-7 and -1. Can I have -7 for an answer? No, because negative 7 plus 2 is negative 5, and I can't do the log of a negative 5. Can I have the negative 1 for an answer? Yes, I can. Negative 1 plus 2 is a positive 1. Negative 1 plus 6 is a positive 5. So those are both all right. So I'm just going to use x equals negative 1. All right, number 9's a little bit different, but I'm going to see if you can do it. So you started this one by doing what?
Subtracting the log.
Log base 2 of x minus 7 minus the log base 2 of x plus 8 equals our 4. So when we moved that over, it made it negative. So since we were subtracting logarithms, when we combined it into one expression, we had log base 2 of
X minus 7 over x plus 8.
x minus 7 over x plus 8, because it changes it to a division problem, equals our 4. Rewriting that in exponential form, I would have
2 to the 4th
2 to the 4th equals x minus 7 over x plus 8. Then I had to get rid of my fraction. That was a plus, right?
16. Oh,
So, 16 equals
Wow.
x minus 7 over x plus 8.
multiply
that
the
up.
x plus 8.
We multiplied by the x plus 8,
Wow, this is just fun.
which means we had 16 times x plus 8 equals x minus 7. And then we had to solve that equation. So we used our distributive property and got, oh, come on board, behave. 16x plus 128, I didn't multiply it, equaled x minus 7.
Subtract the x and add the 7.
We what did we do? Subtracted the x and
Added the 7.
128.
subtracted the 128 because we don't want to move the 7 over here or we'd have nothing left there, right?
Oh,
Oh, snap.
So then we got, go over here, I need more room. 15x equals negative 135. And when we divided by 15, x equaled negative 9. And then we said, can we have negative 9 for an answer?
no.
No. So all that work just to get no solution.
Jeez.
There's no solution you wanted.
There's no solution he wanted.
No solution. Good. Good learning, learning experience.
All right, well you did really good because you remembered, oh, I got to change that to a division, and you went from there. All right, whole different kind of problem because now we don't have the word log in there anymore. So we have some expressions that do not have common bases. If you can rewrite them with a common base, that's the easier way to solve the problem. We'll get to some later that you can't rewrite with a common base. So, in other words, 64 I can rewrite as a base 2 exponent, right? 64 is 2 to what power?
8.
6.
6. 2 to the 6, right? 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, 16 times 2 is 32, and 32 times 2, 64.
Is that easy?
So, I am going to replace the 64 with 2 to the 6th power. And then I'm going to simplify it from there. So I'm going to have 2 to the 5x minus 3 equals 2 to the, and again I have to use my distributive property right there, so I would have something like 18 minus 54x, right?
You know what you times those.
I times those by 6, because when I raise to a power, I multiply my exponents, right? So 6
okay.
times 3 was 18, and 6 times negative 9 was negative 54.
Oh, those ones on the left stay the same.
These stay the same because I didn't do anything to this side, did I? So now that I have them written with a common base, basically I'm just going to ignore that the base is there. If my bases are the same, my exponents have to be equal to each other. And so now my problem is just going to be 5x minus 3 equals 18 minus 54x. And I'm going to solve accordingly. So if I want to solve that, I would add the 54x and add the 3. And I would have 59x equals 21, so x equals, oops, 21 over 59. Now these ones we don't have logarithms, so we don't really have to check our answer. Any answer should be good. So 21 over 59. So on the second one here, the 100 we can write as
5 to the 4.
10 to the second power, right? I want to have a common base,
That's right.
so 10 to the second power.
10 to the deuce.
And then I'm going to use my distributive property there. And so I'm going to have
4 minus 4x. So then we don't even have to, we'll just,
now you can just ignore that the 10 is even there because now they're the same, right? So, negative 6x equals 4 minus 4x. We are then going to
add the 4.
add the 4x, so negative 2x equals 4. Divide, and our answer is negative 2. All right, number 12 again is a little bit different, but we'll see if you can figure out how to do it. But we did 64 earlier and said we could do that as 2 to the 6th power. 32 we can write as 2 to the 5th power. So we're going to have 2 to the 6th equals 2 to the
Negative 5x minus 15.
negative 5x minus 15. And now that they're both base 2, we can ignore the 2's. It was negative 5x minus 15, so it should have been negative 5x minus 15 when I rewrote it over there. Okay, that means we got a plus 15 instead. That'd make a difference, wouldn't it? So 6 plus 15 would give me 21 equals negative 5x, and then I'm going to divide by negative 5. There, now we probably have the right answer.
I think so.
All right. Negative 21 fifths.
You are a human.
You doubted that before?
That's your math robot.
It's hard to see when you're up here and you're going from there to there because you're just... All right. Same kind of thing here. Now we just have a little crazier exponents. So we have 27 to the 3x minus 3 power equals 3 to the x squared plus 2x minus 27 power. Again, we want to try to write it with the same base. We can write 27 as 3 to the third, 3 cubed. So 3 to the third raised to my 3x minus 3 would equal 3 to the x squared plus 2x minus 27. Again, we're just going to multiply that out. So 3 to the 9x minus 9 equals 3 to the x squared minus 2x minus 27. Once we have them where we have the same base, we can just set the exponents equal to each other and solve. So 9x minus 9 equals x squared minus 2x minus 20. Oh, that's supposed to be a plus. Gosh, dang it. How come I keep changing my signs? X squared plus 2x minus 27.
Donald already has an effect on
I
you.
know. Made me lose my mind. So if I want to solve that, I have to set it equal to 0 because I have a quadratic expression.
Shit.
So I'm going to subtract my 9x and add my 9. So 2x minus 9x would be negative 7x. Negative 27 plus 9 is negative 18, right? And I got to factor that out. X and x, plus and a minus. A positive 2 and a negative 9 would give me a negative 7 in the middle. And so my two answers would be negative 2 and 9.
Is that gonna substitute those, or what's?
No, because we don't have logarithms, so we don't have to worry about having anything that's undefined. So number 14, same kind of thing. I have 2 to the x squared minus 16x plus 24 equals 16 to the 9 minus 3x. I can rewrite 16 as 2 to the 4th. And so 2 to the x squared minus 16x plus 24 equals 2 to the 36 minus 12x. So x squared minus 16x plus 24 equals 36 minus 12x. And I want to solve that, so I'm going to.
Flip it on this, or get on the other side.
So I'm going to add my 12x and subtract my 36, right?
Yeah.
And I would end up with
X squared minus 4x minus 12.
x squared minus 4x minus 12 equals 0. And then, of course, I get to factor. That's going to factor into a positive 2 and a negative 6. And so that means my two answers would be negative 2 and 6. All right, try number 15 then. For 15, we have 5 to the x squared minus 24x plus 22 equals, and for 25, we rewrote it as 5 to the second to the 3 minus 8x. So we would have 5 to the x squared minus 24x plus 22 equals 5 to the 6 minus 16x. So x squared minus 24x plus 22 equals 6 minus 16x. When I move them over, I am going to
X squared
add my 16x and subtract my 6, which gives me x squared minus 8x plus 16, if I remember what you said right.
I feel like you're singing the 12 Days Christmas.
And if we factor that, that factors into, now we're all going to have that song playing in our head. X minus 4 and x minus 4.
So x is 4.
So x is 4.
Two turtle doves, 3 red and oh, I think I said it backward.
I feel like you guys are all sleeping today.
Relax.
Stayed up too late watching that fiasco of election.
People are stressed about it.
All right, we are now going to solve ones where we can't rewrite them with a common base, right? There's no way to write 8 to the same power and 3 to the same something power. So what we are going to do is solve them by making logarithms. When we take the log of something, we can then take the exponent and put it out in front, and then it's no longer going to be part of our exponent. So I'm going to rewrite these both with the word log in front. So log of 3 to the y plus 9 is going to equal the log of 8. Now that I have them written as logarithms, I can then take my exponent, move it out in front like we did yesterday, right? So we're going to say y plus 9 equals the log of 3, or equals, dang it, I don't know what I'm doing today. Just because I'm recording, that's got to be it. Y plus 9 times the log of 3 equals the log of 8. Better put my parentheses. I want to solve it for y, so the next thing I probably would want to do is divide by the log of 3, right? So y plus 9 is going to equal the log of 8 divided by the log of 3. I could write it as a fraction, but since I'm going to use my calculator to evaluate it anyway, I'm just going to use a division. And then lastly, I need to minus the 9, right?
What?
This is a plus 9 here, so to move it over here, I got to minus the 9, right?
Alright.
Y is going to equal the log of 8 divided by the log of 3 minus my 9. Now I'm going to grab my calculator, round my answer to the nearest hundredth, and I don't have my calculator. There it is. Loaned it to somebody this morning. They laid it on the podium now, so I'm good.
Did you find those calculators?
Log,
Yeah, I
Jordan
did.
had it in her
Oh.
backpack.
Stole it for the night.
Jack Day got caught.
I was so scared when I went
Oh.
home and saw it in my backpack. I was like, oh my god, what do I do?
Bring it to class the next day.
Yeah, no, I did.
So, what did you get rounded to the nearest hundredth?
Negative 7.11.
-7.11. Everybody getting that?
Yeah, it's rounded it wrong.
Oh, okay. Yes, we do have to round it up. So, same thing here. I have my variable and my exponent. I can't rewrite it with a common base, so I'm going to take the log of both sides. So the log of 15 to the negative 7y is going to equal the log of 2. The reason I do that is because then I can take my exponent and multiply it by my logarithm and not have it be in my exponent anymore. So negative 7y log of 15 is going to equal the log of 2. So if I want to solve that for y, what would I do with that expression?
Plus divide the 7.
Divide by,
The log of 15.
okay, both of them we're going to end up dividing by, right? I would probably divide by this one first, but it doesn't make any difference.
Oh.
So negative 7y would equal the log of 2 divided by the log of 15. And so y is going to equal the log of 2 divided by the log of 15 divided by our negative 7, right? I should get the same answer either way. I'm going to punch it in the other order, but see what if I get the same thing. To 2 decimal places, oh, to the nearest hundredth, same thing. I would get what? Negative 0.04. Yep. All right, try number 18 then.
Alright, this is chocolate.
So first thing we did was what?
Yeah.
Log of 3. And then negative 6.
I just moved.
Log of 2.
Some water.
Then we had
You divide the log of, or put the negative 6 first.
A little canola oil.
and then we have
Divide the log of 3.
What? Divide the negative 6, right?
Yep.
that punched in there?
Yeah, I got it already.
You got what?
You get it.
0.11? Negative, yeah, negative 0.11.
Negative 0.11?
Yeah.
They're going to put negative 0.11 just because it looks prettier, but
Is that how we have to punch it in on Alex? With the zero?
I'm going to guess if you don't put the 0, it'll say it's correct. However,
Oh, however.
you know,
Oh, you call him Alec, huh?
Alex?
Alex.
I just have a list, we just kind of go, I don't hear it very well.
All right.
Sure.
Now we're going to do base E ones. When you have base E problems, same kind of thing, you want to get that exponent out and put it in front, but instead of doing the log, you're going to do the inverse of base E, which is the natural log. And so, we're going to say that the natural log of e to the x equals the natural log of 6. We can then take our x and move it out in front. So x times the natural log of e equals the natural log of 6. Now, the natural log of e, those two things are inverses of each other, always will give you the same number. What is the natural log of e? Try it on your calculator. And you probably have to do e to the first because you know all these calculators are picky. So natural log of e to the first power.
1.
You get 1. So the natural log of e is always equal to 1, and that's why we use natural log instead of log, because that's just going to make that 1. X times 1 is x, so we get the natural log of 6. We still have to compute our answer. It says that we are going, oh no, it's, where does it say? Round our answer to the nearest hundredth. Let me see what we got typed in there. Natural, oh, nope, remember when we did E on our calculator, we didn't use the caret, we just put the number in parentheses like that?
Oh, yeah.
Okay.
It's weird, I know it, but that's the way the Casio made it to happen. So now we're just going to do the natural log of 6. What is the natural log of 6?
1.79.
I didn't do it yet, so I don't know.
Yeah, it's 1.79.
Natural log of 6 is 1.79, okay. So 1.79 should be your answer. Melanie's going to wish she was here at class. When she's watching this tomorrow, we should all say, hi, Melanie. So, same thing at number 20. If I'm going to solve that, because I have a base E, we're going to use the natural log instead of a log.
Can we just skip everything and just do ln 7?
You could.
Well, then,
So 9y natural log of E equals the natural log of 7. So I have 9y equals the natural log of 7. And I still have to do what to solve that for y? I have to divide that by 9, right? So y is going to equal the natural log of 7 divided by 9. And then I'm going to punch that into my calculator.
oh, yeah, you can't just do that.
Well, there's a 9 on our y this time, right? So we got
Yep, what she said.
0.22.
Yep.
What she said. All right, do number 21 then. So if I show my work, I'm going to do the natural log of e to the y plus 6 equals the natural log of 12. This is then going to go out in front. Y plus 6 times the natural log of e equals the natural log of 12. Natural log of e is 1, so I can just basically get rid of it. And when I move this to the other side, I have to subtract it. So y is going to equal the natural log of 12 minus 6. And you got,
3.52.
so y equals negative 3.52
That's what he said.
for your answer.
That's easy.
Yep, that's what he said. I heard him.